Hi grade 10s, I am going through the principle of conservation of charge. This is on page 214 of your Solutions for All textbook. How we start this section is with the definition of what the principle of conservation of charge is. So from your exam guidelines, you will read that the definition of this is that the net charge of an isolated system remains constant in any physical process. So you know you need to memorize that, but this teaches you so much that you can use in the application of the principle of conservation of charge. So I'm going to go through, I think there's 3 or 4 parts here that I'm going to break this down for you guys and explain bit by bit. So I'm going to conquer this green and orange stuff first, and then I'll go on to the mathematical stuff after. So the first thing that we need to look at over here is isolated system. So if something is in isolation, it is completely removed from its surroundings. So an isolated system means that the spheres that you are working with that are used in the example must be insulated, isolated or insulated from the surrounding area by doing one of 2 things. They must either be suspended on string, or they will be placed on insulated stands. This way, the actual sphere carrying the charge will be isolated from the system, isolated from its surroundings, so it will be an isolated system. Right. Secondly, this definition is only true when the spheres are of identical size and they are on insulated stands or suspended by string. So I'm going to say they must be insulated or isolated. The word you would use would be insulated, protected from their surroundings either by suspending or standing on insulated stands. And these spheres also have to be identically sized and they must be conductors. So you will normally use metals. So identically sized and conductors, which means that the spheres that are normally used are metals because they allow the charge to move in and out of the sphere. Right, then the next bit that I wanted to speak to you about was the physical process. So in the physical process that we're going to talk about with these 2 or 3 spheres in every different example that is given to you, the physical process will be the 2 spheres coming together and touching each other or moving apart or whatever it is. So that is normally when contact is made. Okay, so contact is made between the 2 objects, and that is the physical process. It is not a chemical one, it's a physical one. Right, and then the big mathematical portion of the principle of conservation of charge comes from the definition as well. It says that the net charge of an isolated system, the whole system, remains constant in the process. So that means that the total charge, we can write total charge before is equal to the total charge of the entire system after. So if I were to give you a question that said, before contact there are 2 spheres, the first sphere has a charge of plus 7 coulombs and the second sphere has a charge of minus 2 coulombs, we could say that the total charge here before is equal to the total charge after the contact has been made. So the charge before would be positive 7 added to negative 2, which is positive 5 coulombs. Now, that is the entire charge before, which means that the entire charge afterwards would have to be positive 5 coulombs. But due to the nature of charges, protons and electrons, you know that like charges repel, or rather the electrons would move, the protons would repel, but they would stay in place. And your opposite charges would be attracted to each other. So if you have two spheres that are both positively charged, those electrons would be equally interspersed between each of them. So your electrons are not going to stay in one, be more negative, and the other be more positive, or have an extreme deficiency of electrons over here. So what you would see happening is that the number of electrons would be split equally between the two. So you would find that the number of electrons would be split equally between the two spheres. So this positive 5 is the total charge of this. However, this is the charge. We need to find the charge on sphere 1 or sphere 2 afterwards. So we would simply say that the charge divides itself equally between the two spheres. This 2 is because there are 2 spheres. So over here, each would have a charge of positive 2.5 coulombs. So this leads us to an equation, which is the formula for the principle of conservation of charge. So the charge on each sphere after is equal to the total charge before divided by 2. Okay, so that is our formula. So we could have easily said the total charge on each sphere after is equal to the charge of the first one added to the charge of the second one divided by 2, because there are 2 spheres. That would give us the exact same answer.